Let us evaluate the integral of sine to the power of 13 of x. When dealing with an integral of sine and the exponent is an odd number, you would first need to factor out 1 sine of x, making this the integral of sine to the power of 12 of x multiplied by the factored out sine of x of dx. Next step would be to transform the remaining terms according to their trigonometric identities. For the Pythagorean identity of trigonometry, know that sine squared of x plus cosine squared of x would be equal to 1. Since what we need here is a sine, transpose cosine squared of x to the other side, which makes this sine squared of x be equal to 1 minus cosine squared of x. Now that you have that, we would need to make this into a sine squared of x form. "12 divided by 2 would be equal to 6. So it would be raised to the power of 6 and copy the rest. Now that we have this, we can now transform this one. And there are two ways in which we can proceed here. It would be either to expand this as it is now, or we can first substitute cosine of x as another variable in order to make it easier. So that's what we're going to do. Let u here be cosine of x. And when dealing with a u substitution or any variable substitution, you would next take the derivative of what you're substituting. For this, the derivative of cosine of x would be equal to negative sine of x and multiply this by dx since it is respect to x. And the last step in here would be to isolate dx, meaning transpose this to the other side, which would be equal to du over negative sine of x. Now that we have our values here, we can now substitute it, making this the integral of 1 minus u squared, since this is cosine squared of x, to the power of 6 multiplied by sine of x. And the dx right here is equal to this, which is negative du over sine of x. You can see here that sine of x would cancel, leaving you with a negative du. And we can put this negative sign outside the integral. So this is what we are left with now. Let me just put here. And the next step would be to expand this expression now that is much more simplified. The formula for this, the expansion of to the power of 6. A minus b to the power of 6, which represents this one as 1 is a and b is u squared. Let me just write it here. This is according to the formula. And for the formula for this expansion, it would be equal to 1 multiplied by a to the power of 6 minus 6. For a here, it would be descending by 1 power, which would be a to the power of 5. And for the b value, it would be ascending to 1 power. And so add b here, plus 15 multiplied by a to the power of 4 multiplied by b squared minus 20 a cube b cube plus 15 a squared b to the power of 4 minus 6 a multiplied by b to the power of 5 plus 1 multiplied by b to the power of 6. Just a quick tip on how to memorize expansions like this. for the variables a and b in here. For the variable of a, always know that it is descending by 1 power. You can see here, it would be 6, 5, 4, 3, 2, 1 until there is nothing left. And for the b, originally there is no b value here because it would be ascending by 1 each time now. And for your coefficients in here, it is based on the Pascal's triangle. And for this, whenever you are dealing with a negative here, the sign would be just reverse each time. So that is just a quick tip on how to memorize. And without further ado, let us now substitute in here. A here is 1, so this would be 1. 1 to the power of 6 is simply 1, minus 6 multiplied by a to the power of 5. Always know that a is 1, so it does not really matter, and just focus on the b value. B here is u squared plus 15 multiplied by b squared. B squared is u squared to the power of 2, which would be equal to u to the power of 4, minus 20, a cube is 1 again. B cube would be equal to u to the power of 6, plus 15, a squared is 1 again. B to the power of 4 would be u to the power of 8, minus 6, a is 1, b to the power of 5 would be equal to u to the power of 10, plus 1 multiplied by b to the power of 6 would be u to the power of 12. So this would be the whole expansion regarding this one, and just put du after it. Now that you have that, the next step would be to integrate this one by one. And don't forget to put the negative sign in here first. Let me just put a bracket which would represent the integral of this one. Starting with this, the integral of 1 of du would be equal to u minus, for this one, 6 multiplied by the integral of u squared would be u to the power of 3 over 3, plus 15 multiplied by the integral of this one, which would be equal to u to the power of 5 over 5. These are just power rule of integration. Minus 20 multiplied by the integral of this one, which would be u to the power of 7 over 7, and so on. And for this one, let me just continue in here. We can put this as 1 over, let's just put it this way, u to the power of 13 over 13, and add plus c. Next step would be to simplify each of these, and also to distribute the negative sign among these brackets. Six divided by 3 would be equal to 2. 15 divided by 5 would be equal to 3. But again, distributing the negative sign, it would be negative 3 u to the power of 5 plus, because it is negative and negative, 20 over 7. Just put it in fraction form when it can't be divided into a whole number, multiplied by u to the power of 7 minus 15 over 9. You can reduce this to 5 over 3 multiplied by u to the power of 9 plus 6 over 11 u to the power of 11 minus, for this one, we can rewrite this as 1 over 13 multiplied by u to the power of 13, and add the constant of integration. Never forget to distribute the negative sign, which would be equal to this one. Now for for the final answer, you can just revert all u values here into cosine of x. And for your final answer, for the integral of sine to the power of 13 of x would be equal to negative cosine of x plus 2 cosine cube of x minus 3 cosine to the power of 5 of x plus 20 over 7 cosine to the power of 7 of x minus 5 over 3 cosine to the power of 9 of x. And let me just continue in here. Plus 6 over 11 cosine to the power of 11 of x minus 1 over 13 cosine to the power of 13 of x plus, see,